Hi students, in this video we are going to derive the formula Q is equal to ms delta T. The formula is Q is equal to ms delta T. Q is mass heat absorbed by the substance. Heat absorbed by the substance. M is mass of the substance. Mass of the substance. S is specific heat. Delta T is change in temperature. That is final temperature minus initial temperature. Take two beakers of the same size. See, two beakers I am taking. Take two beakers of the same size. Say this is beaker A and this is beaker B. Put 250 grams of water in the first beaker. 250 grams of water in the first beaker and 1000 grams of water in the second beaker. Put 250 grams of water in beaker A and 1000 grams of water in beaker B. After that, we have to take initial readings. Take or record initial readings. Initial readings of temperatures of water in the two beakers. We have to take temperatures of the waters present in the two beakers. Now we have to heat up the water present in the both beakers to reach 60 degrees centigrade. Now heat the water, heat the beakers till the temperature of water rises to 60 degrees centigrade. Heat the two beakers till the temperature of water reaches 60 degrees centigrade. We notice that beaker B takes more time to reach 60 degrees centigrade than water present in A, that is beaker A, because here more quantity, beaker has more quantity of water, whereas beaker A has less quantity of water. We notice that beaker B takes more time to reach 60 degrees centigrade. Here beaker means water. Water present in the beaker B takes much time to reach 60 degrees centigrade. So here write water in beaker B takes much time to reach 60 degrees centigrade. Beaker A, water in beaker B, beaker A takes less time to reach 60 degrees centigrade because more quantity of substance needed more heat to reach certain temperature. For the same change in temperature, amount of heat absorbed by the substance is directly proportional to the mass of the substance. I am writing here. For the same change in temperature, the amount of heat absorbed by the substance is directly proportional to mass of the substance. So we can write Q is proportional to mass. Say this is equation 1. Now take 1 liter of water in a beaker, heat it over a constant flame. Notice the temperature change for every 2 minutes. We will notice that temperature change with the time is constant. See, I am writing all these steps. Take 1 liter of water in a beaker. After that, we have to heat it over a constant flame. Over a constant flame. We have to observe temperature change for every 2 minutes. Notice temperature, change in temperature. We notice that change in temperature rise with the time is constant. I will explain it. Suppose initially the temperature of the water, say 20 degrees centigrade. After 2 minutes, say it is 30 degrees centigrade. Say initially the temperature of water is 20 degrees centigrade. I am writing here minutes. First 2 minutes, after 4 minutes, after 6 minutes, after 8 minutes. See, we are taking readings after every 2 minutes. Here 2, next to 4 minutes, next to 6 minutes, next to 8 minutes. Initially, the temperature of water is 20 degrees centigrade. At the end of 2 minutes, it will be, say, 30 degrees centigrade. At the end of 4 minutes, it will be 40. Next, after the end of 6 minutes, it will be 50 degrees centigrade. After 8 minutes, the temperature of the water is 60 degrees centigrade. From this, we see that difference between this temperature, 30 minus 20, that is 10 degrees centigrade, 40 minus 30, 10 degrees centigrade, 50 minus 40, that is 10 degrees centigrade, 60 minus 50, that is 10 degrees centigrade. There is constant change with the time. Here, for every 2 minutes, there is only 10 degrees centigrade change. So, this can be written as Q is proportional to delta T. That means change in temperature or substance, heat absorbed by the substance is directly proportional to change in temperature. So, temperature rise with the time is constant. Change in temperature rise, change in temperature rise with the time is constant. Q is proportional to delta T. This is equation 2. From equation 1 and 2, Q is proportional to M delta T. That is, Q is equal to ms delta T. Here S is specific heat of the substance. Specific heat of the substance. For S, I am writing equation S is equal to Q by M delta T. Q by M delta T. From this equation, we get units for specific heat. That is, S is equal to Q by M delta T. See, Q is measured. Q means here heat absorbed by the body. Q is measured in calories in a CGS system by meters. Here, mass of the object is gram. Change in temperature, that is measured in centigrades. So, in CGS system, units for specific heat is calorie per gram centigrade, degree centigrade. In SI system, see here, Q, heat is measured in joules. So I am writing J. Mass is measured in kilogram. Temperature is measured in Kelvin. So unit for specific capacity in SI system is joule per kg Kelvin. Specific heat. Specific heat, right? Specific heat of a substance is defined as the amount of heat energy required to raise the temperature of unit mass substance by 1 degree centigrade is called specific heat of the substance. I am writing here. The amount of heat energy required to raise the temperature of unit mass substance, temperature of unit mass substance by 1 degree centigrade is called specific heat. I am making it clear. See here, suppose say one substance here, say water is present in this beaker. Its initial temperature be 20 degrees centigrade. Now we heat it. Its temperature is 21 degrees now, 21 degrees centigrade. Certain heat is supplied to this water. Initially, its temperature is 20 degrees centigrade. So after supplying some heat energy, now final temperature is 21 degrees centigrade. That means 1 degree centigrade is increased. The temperature of this water increased by 1 degree centigrade. So to increase this 1 degree centigrade, we supplied some heat energy. That supplied heat energy is called specific heat of the substance.